Hello, this is the video I am going to do today in attempts to give you all some idea of some of the many systems that are placed inside vehicles today. The future will hold many more of these electronic systems. This video that I am doing today is for my vehicle electronic class here at Clemson University. And the system that I'm going to attempt to convey to you is called the adaptive cruise control system. A lot of cars made today are equipped with adaptive cruise control systems. Because I don't own a car with adaptive cruise control, and my instructor suggested that we build something to display the operations of the system, I decided to use the LEGO Mindstorm NXT kit. These kits come with 100 different plus LEGO pieces, and they also include a brick, which is more like the brain or the CPU of the robot. It contains motor, different sensors, and different other things to power the robot, like a battery pack or maybe a charger. Each robot kit is different. I decided to build a standard robot with the ultrasonic sensor sticking in the front of it. Now there's a big difference between an ultrasonic sensor and a radar sensor used on vehicles today, but they both simulate the same thing. In other words, the behavior of both sensors are similar. The ultrasonic sensor is an acoustic sensor. For adaptive cruise control systems used in cars today, they use a radar sensor. Why radar versus the acoustic sensor? Is because of the radar transmitter is very much more reliable than those of the acoustics. These radar sensors allows the car to go within the ranges of 45 to 55 meters before the car alerts the driver or automatically reacts on its own to prevent an accident or a collision from occurring. So to build my robot, I use this NXT kit. It comes with a lot of different pieces that's placed in these bags here. I followed a list of instructions and came up with a robot that looks like this, with the ultrasonic sensor in front. Next, I would display what should happen with adaptive cruise control system. Okay, so this is a robot here that I built, and I'm going to start it here. It's going to delay for about 2 seconds before it gets started. But once it starts rolling, it's going to get up to a cruise control setting speed, which is at 100 power into the program. This right here I will use as a simulation of another vehicle, as if this robot is approaching this vehicle on the highway and doing cruising. So I'm going to set this. Wait 2 seconds. Run. Now, this robot is currently running at a constant speed. What's going to happen now is that when this robot reaches within 10 inches of the car, it should slow down, just as it's doing now. And it's going to stay at a constant speed. When it gets within 5 inches, it's going to stop to avoid collision or an accident. Let me remind you that I'm referring in the video as 10 inches and 5 inches because that is the settings for this acoustic sensor placed on this robot. But remember that in real vehicles and cars that we use radar sensors, and the span could be plus or less, and they refer to them in measurements of meters. Allow me time to explain what you're going to see as we run the robot on the floor. I have a friend who's going to assist me. He's going to mash the orange button on the robot. The robot will act as a car on the highway and has already executed its cruise control. He will use a book to simulate another car on the highway in front of the car with the adaptive cruise control. And then we will see what happens. Here's the video as it starts here. When the car reaches the vehicle in front of it, it's going to slow down to prevent hitting the car. If the car in front stops, the car behind will stop. As soon as it takes off, it will adjust back to its original setting of the speed, keeping safety in mind. If my friend was to lift up this book completely, the car would take off and resume back to its adaptive cruise control setting.